Performance analysis of DC shunt motor by using MATLAB Simulink. The performance analysis that is called torque speed characteristics and also speed versus armature characteristics, torque versus IA characteristics. These are the different types of characteristics of DC shunt motor can be understood by using MATLAB Simulink. So this is the circuit diagram of self-excited DC motor that is called DC shunt motor. The field winding is connected in parallel to the armature winding of a DC motor is called shunt field winding. This is called shunt field winding. That's why this motor is called as a DC shunt motor. Here this is called DC supply voltage. Input to the motor is called supply voltage, and this current is called line current. And this current flow into the motor is called armature current. And this current flow into the field winding is called shunt current or field current. Okay. And this is called armature winding, arm resistance RA, and back EMF of this motor is called EB. Supply voltage V. So this is the circuit diagram of DC shunt motor. The next, the nameplate details of the DC shunt motor in MATLAB, we have to choose like this. So output power of the DC machine, that is called motor, is called 5 HP DC motor, and armature voltage is called 240 volts, and speed is called 1750 RPM, and field voltage is called 300 volts. These are the maximum rating of nameplate details of this motor. So output power is 5 HP, 240 volts, armature voltage, and 750 RPM. Speed, field voltage 300 volts. So this type of motor we have to choose in MATLAB Simulink. Okay, and then next, so these are the different types of torques in motor. Armature, TA is called motor torque or gross mechanical torque. T loss is called lost torque or due to friction, windage and iron losses. And TH is called sharp torque or load torque, and power output is called torque into omega. Power output is equal to P is equal to torque into omega. Then next, we know from the nameplate details of this DC motor, power output is 5 HP, that is equal to convert 5 into 746 watts to convert horsepower into watts by multiplying 746 into the power. Then we get so power output and 3730 watts. Okay, and then angular velocity, that is called radians per second, 2 pi n by 60. Speed is called 1750 by substituting her. So we will get 183.16 radians per second. And then what is the load torque here? Load torque is nothing but that is called shaft torque, that is equal to power by omega. Power output by omega, that is called 3730, this power, and then speed in radians per second 183.16. That is equal to 20.36 Newton meter. Approximately 20 Newton meter is called load torque of this motor. Okay, and next, these are the characteristics of DC shunt motor. Speed versus armature current IA. So ideal condition, this is the characteristics ideal condition. Practically there is a voltage drop present, IA drop, that because of this speed is slightly decreases. The practical characteristics are like this. Speed versus armature current. Speed is approximately constant, only small drooping characteristics of this motor. This shunt motor is called constant speed motor. Okay, here even though this armature current is changes, speed almost constant, small drooping characteristics. Okay, the next, torque versus armature current, torque versus IA characteristics. Armature torque versus armature current is linearly increasing. So proportional torque is equal proportional to IA, that is equal to torque is equal to K into pi into IA. The torque is equal to K into IA. Okay, so this is the torque versus characteristic armature current characteristics of DC shunt motor. And then speed versus torque characteristics, here there is a small voltage drop because of this speed is decreases, small drooping characteristics. Practically small, there is a small drooping characteristics, and ideally straight line. So these are the three different types of characteristics of DC shunt motor can be understood by using MATLAB Simulink. Open MATLAB Simulink. Okay. So opening MATLAB Simulink on the screen, press 2 times mouse left click like this. Right here, DC machine. Then open like this. Initially, it takes some time to open these components. Okay. Like this is called DC machine. The DC machine in MATLAB looks like in this way. This is called DC machine. This DC machine is having load torque TL, armature terminals, positive terminal, negative terminal, and field terminals, positive and negative terminals. Load torque TL and armature terminals and field terminals, and next M is called, it's connected to the bus selector and is having different types of characteristics. We can get the characteristics from this bus selector by connecting the bus selector to the M. Okay, and here this motor, first we have to take one DC voltage source. DC voltage source. This is called DC motor. Then right here DC voltage source. DC voltage source. Select this DC voltage source, and then it will be displayed on the screen. Okay. So this is called DC voltage source. Select this DC voltage source and press Ctrl R. It will be rotate like this. Press Ctrl R, select, press Ctrl R, will be rotate like this. Connect this positive terminal to the armature positive terminal. Positive terminal of DC voltage source is connect to armature terminal of positive and a negative terminal negative. Okay. This is called DC shunt motor. That's why field winding is also connected in parallel to the armature winding. So connect in this way. Field winding connect like this. Okay. Field winding and armature winding both are parallel. That's why this is called shunt field winding, and this is called armature winding. DC voltage source. This is DC voltage source, and here constant is called torque. For example, load torque, that is constant. By entering constant by entering constant, right here constant, and connect this load torque, this TL terminal. Okay, in this way. And here the one is there now, so change the, so according to our calculations, load torque is called 20 Newton meters. That's why right here 20 Newton meters instead of 1, right, 20 Newton meters. Then apply, then okay. Okay, so this is load torque is called 20 Newton meters. And this here we have to connect one bus selector. Right here, bus selector. So the bus selector is connected to the M. Okay, the bus selector is having terminals like this. Open bus selector. So these are the different types of signals present in the bus selector. So remove these two and add plus 1 speed in radians per second. Okay. Then next armature current in amps, field current amps. Okay, field current 2 times selected, that's a delete. and electrical torque T Newton meters. First one is called speed in radians per second, electrical torque Newton meter, armature current IA, field current IF in amps. Then apply, then okay, then you will get 4 terminals. Okay, this is called bus selector. Next, so the bus selector is having this type of terminals. Okay, and here connect, take one. The speed is radians per second. That's why to convert in RPM, one gain is required here. Right here, gain. So 2 pi n by 60, 60 by 2 pi by converting like this. Right here, open gain. So here, right here, 60 by 60 divided by 2 pi is called radians to 2 pi, radians to RPM conversion. 60 star 60 by 2 pi into right here pi, then close 60 by 2 pi, apply, then okay. Okay, 60 by 2 pi is called radians to speed conversion. Okay, so like this. And if you want to know this, what is the value of speed, take one display, right here display on the screen, display. Select a display and place here. Speed versus torque. To go know speed versus torque characteristics. This is our speed display. So the next same way, take another display. This is called electrical torque in Newton meters. And the next another display, connect display to here. This is called armature current IA. Take one more display. This is called field current IF. So speed, torque, armature current, and field current. And the next, if you want to display the waveform, take XY graph right here, XY graph. Right here, XY graph. And first one, this graph is related to speed versus, for example, speed versus, this is called speed, and next this is called torque. Speed versus torque, first graph. And second graph, speed versus armature current. This is called second graph. Next, third graph, speed versus field current. Speed versus field current. Take one more graph, torque versus IA characteristics. Torque versus armature current. Connect like this. So like this, all graphs are connected. Okay. First graph is called, x-axis is called speed, y-axis is called torque, speed versus torque characteristics. Second graph, this is called second graph. Second graph here, speed versus armature current. Third graph, speed versus field current. And next, finally, torque versus armature current. These are the different types of graphs can observe by using this arrangement. Okay. Then, so here, what is the motor here? Motor parameters 5 HP, 240 volts, 750, 1750 RPM, and the field voltage is called 300. This is the motor model. Chosen model is called 5 HP, 240 volts, 1750 RPM, 300 volts. Then okay. Okay. And then apply here voltage is 220 volts. 220 volts DC voltage apply. And then load torque is called 20 Newton meters. And these are the displays, the different types of display, the speed with display, torque, armature current, and field current, and okay, and then simulate. Take one power guy is missing. That's why the error is getting like this. So enter right here, power guy, and then simulate. So compiling, after compiling simulation, so we will get the results. For 220 volts supply, for low torque 20 Newton meter, speed of this motor is nothing but 1887. 1887, the speed of the motor. And torque, electrical torque is called 21.11 Newton meters. The torque developed in motor is greater than that of the load torque, then only the motor is rotating. Okay. The motor torque is greater than load torque, then only this motor is rotating. Otherwise, it may be a it cannot handle the load. It may be shared. It will be stopped. The speed is become zero if the load torque is greater than motor torque. If motor torque is greater than load torque, then only motor is shaft is rotating, and then we will get some speed. If the load torque is greater than motor torque, the motor cannot run. Okay. Then next armature current is increases according to the load. The armature current is called 28.44. Okay, armature amps, and field current is called 0.784 amps. Then next, what is this first one? First one is called x-axis connected to the speed, y-axis connected to the armature torque. Then open this xy graph. Then speed versus yeah. So without changing the any settings, automatically the display by adjusting the x-axis and y-axis. By opening the xy graph, automatically the scale will be displayed. Okay, x-axis called speed, and y-axis called here y-axis called torque, x-axis called speed. Speed versus torque characteristics are like this. Okay, then here x connected to this called speed in Newton meter, x is called in RPM 1887, x-axis called speed. So I am changing like this. X-axis called torque, x-axis called torque, y-axis called speed. I am changing the settings like this. Then simulate again. Y-axis speed, x-axis called torque. Okay. Then open xy graph. Then speed torque characteristics will be displayed. Open xy graph. Then speed versus torque characteristics of DC shunt motor. Like this. Here, so this is called speed on x-axis, torque is on y-axis. X-axis called your torque, y-axis called speed. Then simulate again and then open. This is called x-axis, this is called y-axis. First one is called x-axis, 2 is called y-axis. So x-axis is called torque, that's why I connect like this. Y-axis called speed. And the next, this is called, first one is called speed torque characteristics. Then speed versus armature characteristics. So armature current is on x-axis and speed is on y-axis. This is called speed versus armature current characteristics. Then the third one, torque versus IA characteristics. Torque is on y-axis. Torque is x-axis is called armature current. This is called armature current. And y-axis is called torque versus IA characteristics. And then next field speed versus field current. Field current is an x-axis. Field current is an x-axis. Field current. X-axis called field current, y-axis called speed. Like this, connect and then simulate again. Press simulate and then open this first graph, XY graph. After is compiling completed. Stop time is 10 seconds. That's why it is taking up to 10 seconds. The graph will be displayed up to 10 seconds. So XY graph is now, that's why first one is called torque versus speed versus torque. Speed versus this. First one is called, what is this? First x-axis is called torque. X-axis is torque. Y-axis is called speed. Speed versus torque characteristics. Open speed versus torque characteristics. Torque is on x-axis, speed is on y-axis. Then speed versus torque characteristics will be displayed like this flash. Drooping characteristics, speed versus torque characteristics. Here our torque is called 20 Newton meters, low torque. So up to 20, 30, 40. So this drooping characteristics we can observe. When low torque is greater than motor torque, the motor will be shut down. Okay. And the speed is decreases gradually when the low torque is increasing. Okay. So this is called speed versus torque characteristics of DC shunt motor. And then it's coming to the second one. This is connected to the y-axis called speed. X-axis is called current. Speed versus armature current characteristics. Speed versus armature current characteristics. Second one. Speed versus armature current characteristics of DC shunt motor. So wait for some time. It will be displayed automatically without changing any settings. Like this. Speed versus armature current. Is a drooping characteristics, small drooping characteristics. This is called speed versus armature current characteristic of DC shunt motor. Then next one, second one is over. Then third one, this here, x-axis is called armature current, y-axis is called torque. Torque versus IA characteristics. Open this torque versus IA characteristics graph. Press here, fit to view, and then open like this. Torque versus IA characteristics. Torque versus IA characteristics are exponential is increasing. Torque versus IA characteristics. Okay. So these are the characteristics, torque versus torque in Newton meters, and armature current is called amps. The next, finally, what is this fourth one is called, here this x-axis is called field current, y-axis is called speed, field current versus speed. Field current versus speed. Field current versus speed characteristics of DC. This is called field current, almost constant, and speed changes like this. Okay, this is called field versus armature current characteristics of DC shunt motor. So if you want to connect, if you are connecting in reverse manner, then it will be display like this. Here X is called field current. X is called field current. Y axis is called speed. Okay. So these are the characteristics of DC shunt motor.